Hi, welcome to SUSECON 2020. I hope you've been enjoying the conference so far. Today, we're going to be talking a little bit about what makes SUSE Linux something special, what makes it differentiated. My name is Rick Ashford. I am been an engineer here at SUSE for about 12 years. And with me today is going to be Craig Little, who has been an engineer here at SUSE for 4 years. So we're very excited to have you here, and let's go ahead and get started. So just by way of agenda, we're going to be walking through a couple of different things today. First off, we're going to talk about BTRFS, everybody's favorite topic, file systems, right? We'll talk about the kernel a little bit in terms of live patching. We'll also talk about system administration, the ability to do different things using YaST. And then we'll also talk about the actual architecture and how the OS is put together with modular OS. And then we'll talk about a couple other tools and pieces that hang around that aren't necessarily part of the OS per se, but they are tools that we produce to be able to make the experience better for you as a user. All right, so let's talk about file systems. As I said, everybody's favorite topic, right? We're going to talk about BTRFS. So BTRFS is a file system that development began on it back in 2007. It's designed to be roughly feature comparable with ZFS. For those of you who are familiar with Solaris and ZFS, we've been working with it here at SUSE in an official capacity for a little over a decade. So we first released a technical preview for it back in SLES 11 Service Pack 1 in June of 2010. And then it became fully supported in SLES 11 Service Pack 2, which was released in about February of 2012. And then it worked out so well for us that we decided to go ahead and make it the default file system in SLES 12 as of 2014, and that's carried forward into SLES 15 as well. So multiple generations over about a decade worth of experience we've had with this as a file system. So what makes BTRFS so special? Well, for starters, the maximum file system size, theoretical size, is 16 exabytes. It's a huge number. Nobody's actually built anything that big, so it's kind of a theoretical maximum, but that is what the math tells us. Another thing that's really neat about it is because of the way the B-tree file system is set up, you can actually do instantaneous snapshots and capture point-in-time snapshots of the system itself. You can also implement subvolumes so that you can do logical separation between parts of the system, kind of like what you did with LVM, except that unlike LVM, you're doing it at the file system level so that you can control and change things on the fly without having to resize or move around things on the actual file system itself. Another neat thing that you can do, or that it does, excuse me, is to do automatic checksumming. So if you have multiple copies of your data within the file system through its RAID features, then you can actually do automatic checksums where it'll automatically compare the checksums between the multiple pieces of data that you have, and it can use that to help prevent silent disk corruption, which is a really nice thing when you're looking for preserving data integrity. It can also do compression, which enables you to be able to reclaim some of the space on your file on your disk. We support two different We support two different compression algorithms that you can choose between zlib or LZO. LZO gives you its higher compression, so it'll reclaim more of that disk space, but it is more CPU intensive, so it is more likely to potentially interfere or slow down your overall system. Whereas LZO is a much lighter compression algorithm, so it will not have as much of an impact on the system, but it also won't reclaim as much disk space for you. And you can do that compression on either a file, directory, subvolume, or the overall file system level. So you can get very granular in terms of your control of how much you want to compress on your file system. Some other neat things it does is integrated multiple device support. So think of things like your RAID controllers where you're taking and creating different RAID levels and stuff like that. You can do RAID directly within the file system, as well as the pooling like what you were doing in LVM. So you can take all your data and you can get all that pooling, mirroring, and striping and stuff like that. And again, because you're doing it at the file system level, you can make the adjustments to those settings on the fly as you're going, and switch between the different types. And that gives you a lot of flexibility as well as adaptability for your operating system. It is also SSD aware, so it can adapt for doing trim operations and whatnot, so that you can preserve extend the life cycle of your SSDs. A couple other things that it does. Excuse me. It does do online file system defragmentation. So you can go in and straighten it out. So especially if you're on magnetic media like hard drives, you can have it do your defragmentation bits online, so that it'll align the bits to optimize for spindle access times. You can also do, and this is really neat, in-place conversion of existing ext3.4 file systems. So if you haven't taken the leap into BTRFS yet, and you have an existing ext-based file system that you would like to try it with, you can actually convert it in place. The neat thing that it does also is it will make a backup of the file system tree for your ext file system. You can go in, convert it to BTRFS, go play with it. If you don't like it, you can actually then do a restore, and it'll take that file system tree that you had originally, that it automatically backed up, and it will restore that, and you can have full access to your data in the exact state that it was before you before you went and did the conversion. So it's a non-destructive conversion and recovery. Another neat thing you can do is implementation of subvolumes on the subvolume quotas, so that, for example, if lots of times people have used partitions or logical volumes to be able to set limits on var log, so that you don't have some process go spinning out of control, fill up a var log, and fill up the hard disk and crash the system, right? Usually you've had to do hard limits with either a partition or a logical volume for that. Well, you can actually set quota limits for subvolumes. SUSE by default creates a dedicated subvolume for var log, so you can set quota limits on that, and again, prevent out of control processes from filling up the disk and doing that. And the nice thing is that, again, because you're doing this at the file system level, you can adjust those quotas on the fly and essentially do the equivalent of shifting space from one logical volume to the other through the use of subvolumes and quotas, without having to redeploy the system or take the system offline to be able to do all these resizings and changing around. It's a very flexible type of operation. Another thing you can do is batch deduplication. So it's not going to do let's try that again. It's not going to do data deduplication on the fly, but if you have multiple copies of data and you want to run a batch deduplication, you can do that, and it will free up space by making the pointers at the file system level point to the same batch of data on the disk, and it can do that for you, and then it can track those different copies separately, so that if you change one, it does not necessarily change the other. So I'm not going to spend a lot of time going through the full spate of different features that are supported here. I'll just kind of leave this up here for a moment so you can look through it. What you can see, though, is there is a wide variety of different things that are supported, both here and in the next thing. The most important thing I think that people may want to note here is that while we do support RAID 0, 1, and RAID 10, we do not currently support RAID 5 or 6 for your RAID settings. So if you really want to have a RAID 5 or 6, then unfortunately you would have to do that through your RAID card, not through the file system. The other thing that I want to point out here is the lack of we'll call it, we do not provide support yet for device replacing. This would be for a single disk system to be able to connect a disk and transfer everything from one to the other in the file system. That functionality is available upstream in the community. We do not support that right now. We do, however, support the hot add remove of disks. So if you have a RAID-based system, you would be able, if a RAID-based system where the RAID is being done by BTRFS, then we do support being able to do hot add and remove of the disks as part of that process, as part of that file system. Lots of great stuff in there. So, key thing we want to get around here is that, you know, historically within the data center, there's been a lot of hard work that's had to go on in order to do things like storage mirror, your mirroring and your striping with RAID, using LVM to do your pooling and your segmentation and your snapshotting, stuff like that. There are a lot of different tools that were used all over the place to do things, and quite often it required you to take the system offline, or at the very least unmount a file system in order to affect these change. With BTRFS, a lot of these functionalities that we've been looking for historically are all in one place, and enable you to do operations on them without having to unmount the system, without having to take it offline. That's a really powerful thing. And one example of one powerful thing that we've been able to do as a result of this is leveraging the snapshots. For example, we were able to integrate that with the bootloader as well as with the system management tools, such that anytime you do a package install or you use YaST to do system administration, it automatically takes pre and post operation snapshots. Benefit to that being is that, you know, if something goes wrong, you can look at the differentials between your current system and either the pre-install system or a fresh install system to be able to compare and see where things went wrong. If things went really bad, you can actually reboot your system, and in the bootloader, it will have a list of all of your available snapshots. You can select the one that you want, boot into it, and either do forensics and recovery or whatnot, or you can make that rollback permanent and figure out what happened and get the system back offline. Cool thing is that we do not revert the logs when we do that rollback. And we also, when you do rollback, the snapshot or the instance that got messed up is still available to you. So typically when the system goes down, you have to do your forensics first, and then you can recover back to get it up and running. With BTRFS, you can get the system back up and running immediately, and then you still have full access to the logs and to the whatever went wrong to be able to go back and do your forensics and figure things out. Really neat stuff. All right, so now I'm going to turn the time over to Craig, and he is going to help us start talking about live patching and some of the other neat things we can do. And I'll see you again in a couple minutes. Thanks.
Hello, and thank you, Rick, for kicking off the What's So Special About SUSE. What I'm here to continue the conversation with is live patching. And my name is Craig Little. I'm one of the SEs in the West here in the United States. And let's take a look at live patching. Live patching is one of those solution sets that have been around since SLES 12, so it's been around for a little while. And actually, if you had a premium support agreement with SUSE, you also could have gotten it with version 11. So it's actually very mature technology. And it really is all about providing those kernel updates for SLES servers to provide you stability, security, updates without having to stop the kernel, without having to stop any applications or restart any boxes. Very, very cool technology for those folks that are employing those applications that need to be long time running. And so that need to get a maintenance window with downtime associated with it, having to grab maybe application owners, maybe the application administrators to bring them into the fold, you don't have to do with live patching. It really is that no interruption, being able to move things forward. And one of the benefits is it allows you to stay compliant with your environment, to keep it up to date with all of the security vulnerabilities, stability pieces, keep it good, stable without having to reboot the system. Again, looking at something like an SAP environment, SAP HANA specifically, you don't want to have to take that HANA server down very often. So this is why we like to recommend having you guys take a look at live patching. Very cool solution. So let's take a look at the normal methodology of live patching, where you get some updates, you reboot the machine, and then you're clear. Then the next round of updates comes and you get another reboot. Then you're patched for a little while, next round of updates, and this continues until you get to the point of I've rebooted every time that I've deployed updates. While it's good that you deployed those updates, it takes some time to achieve this. So if we take a look at live patching, what we have is a little bit different component. Started out all clear, all patched, updates came in, I patched it, no reboot. And I continue down that environment where it is no reboot, and I can do this for up to a year. And in doing so, I'm staying patched, I'm staying vulnerability free, or at least known vulnerability free, and I'm able to move things forward without having to restart my box. Support calls for a once a year reboot to be able to kind of consolidate everything. Typically, you would tie that with when you are potentially taking down your data center, dealing with UPS maintenance, dealing with firmware updates on your routers and switches and things of that nature. So once a year, you would want to do that. With SLES 15, we actually have a little bit of new technology. We're moving forward with what we're calling KLP, Kernel Live Patch, and it's actually a merger of the kgraft and kpatch technologies. When kernel live patching first started, there was a couple of folks that were deploying it, and they each kind of had their own methodology. So what we're doing is incorporating those together and kind of merging a couple of those. And in SLES 15 is where we have those first pieces. Doesn't change anything from a capability perspective, but the tools change just a hair. The first one is the KLP tool, and that gives you the status, patches, blocking information. And then you have the zipper lifecycle. And this is an extension to the command line zipper tool that gives you, and I'm going to go ahead and read it here. It gives you it requires, the lifecycle data SLE module live patching package to be installed to get it. It adds the zipper lifecycle command, which then shows you what live patching patches are available in the repository. So it's a nice little extension to the zipper toolset. How this actually works. We use ftrace to be able to do a quick redirect on all of the function calls. This is what allows us to do a lazy write deployment, in that we don't stop the kernel, we don't halt the kernel, we don't stop anything. We just start doing redirects to the new code. And this is great unless you have a long-running process. And one of those, the KLP command, has that status and has the process subcommands in it to let you know, am I fully patched? Are all processes using the new patches? And it'll tell you what processes might need to be restarted. And I'm talking just individual processes, not the entirety of the server. But we do the ftrace redirect to the new function, and everybody is happy, everything's patched, all the vulnerabilities are taken care of. And it's beautiful to be able, in how quickly it can patch a system and take care of vulnerabilities. Let's talk about YaST. Hopefully everybody knows, or you might not know, what does YaST stand for? It stands for Yet Another Setup Tool. This is something that we have used over the years. Basically, the project started very early on in '96, so we've had it for quite a while. But those of you that are old school may remember SMITI on the IBM AIX side of things. There's been a variety of setup tools in a variety of applications. And it's good things. It's installation and configuration. It has, YaST specifically, has a graphical interface tied to GNOME or KDE. And it also has an ncurses interface that you can pick up off of the command line. It's modular, extensible, and so you add some packages, and now all of a sudden you get some new capabilities. One of those is the auto YaST configuration piece that allows you to use YaST to modify an auto YaST script. Very cool little capability that not a lot of people are aware of. So I'm going to kind of throw that one out. It includes the ability to manage the firewall. Notice how quickly and easily you can go see how this firewall is set up, how to make changes to it, what services, what ports, and all of these pieces. It's really easy to take care of through YaST. Here's the configuration management for networking example. We also have the services management example, and this is one of those where from the command line, it's potentially a little more complex. pretty easy inside of YaST. I've got a customer who loves to include YaST on the servers that he deploys because he goes, the day-to-day stuff's easy via command line. Those are things you know how to do. It's easy, you do them all the time. Life is good. But for those complex things or the things you don't remember or those things you only do once in a while, YaST is a great component to help you take care of those in an easy fashion. So it's a good helper. And it's one of those sort of hidden gems around SLES. We also have the partitioner pieces. This is an example of SSH Key Management done via the ncursus interface. Very, very clean. Something to keep in mind for you PuTTY users out there. If your YaST does not look like this, you need to change the character set in PuTTY. And I think you need to take it to like the Western ISO character set, and that will take care of that piece for you. So something to kind of keep in mind to make it look good, make it more usable. Another quick tip is the letters on the OKs, the O on the OKs, for example, allows you to, if you hit the Alt in that letter, to move through that piece. Now on to modularity. Modularity is one of those pieces that's the foundation for SLES 15. We started it in version 12, we're really moving it forward with version 15 even further, and that's really to bring about our support of a multimodal IT system. Multimodal IT is that support of an IT environment that has legacy infrastructure-based pieces, hosted pieces, data center pieces, cloud pieces, physical servers, virtual servers, containers, DevOps. You've got all of these pieces, and having one operating system support all of these methodologies of using an operating system is tough. At SUSE here, we have taken it and approached it via modules, to where you can have the modules that support your traditional infrastructure, as well as having the modules that support the software-defined infrastructure, because they're very, very different, but they're very different use cases. But from a code perspective, all the modules are built around this common code base. And so a common code base, it really gives you a couple of key benefits: consistency, silicon agnostic computing, simplicity, and improved systems management. We support, from a hardware point of view, everything from a Raspberry Pi up to an IBM Z. So from one of the least expensive systems up to one of the more significantly more expensive systems. SLES is supported across all of those, which is kind of a cool thing, that I can go fire up a Raspberry Pi and use it and run SLES on it, as well as fire up a multi-million-dollar Z. So it's kind of some fun stuff. But coming back to multimodal operating systems, you can see from that traditional infrastructure, it's often bare metal or virtual machine, but it's multiple use cases, it's large, it's typically manual installation, variety of updates, upgrades, various packages, potentially different upgrade paths, and it can get a little bit on the large size. Whereas looking at software-defined infrastructure, we really have this concept of a single use case. We have potentially scaling wide, so multiple systems, automatic deployment more often than manual deployment, and needing to be always up to date, purpose-driven or purpose-built systems. It's going to do just one thing, and one thing hopefully very, very well. It also ends up with an environment that's typically very, very small. Notice these are kind of diametrically opposed lists here, but we've got one operating system that supports both. And we do that through the use of those modules, to where you can load up the modules for the software-defined infrastructure versus the traditional. It allows you to keep a lean operating system, yet supporting the environments that you need. So again, everything is a module, everything becomes simple to add, and you end up with a single ISO to start with, and then you add all of the appropriate modules and the patterns to get the server to be installed to do what you want it to do. So SLES 15 portfolio. There's a couple of key items on here that I want to kind of talk about quick, because these are those key elements that make SUSE unique. One of them is around SLES for SAP. We've got a complete SAP-based distribution with all of those components necessary to run the SAP HANA or the SAP application server in a very quick, easy fashion, very powerful, very clean. We also have high performance computing based distro. Real-time. Real-time is one of those pieces that not a lot of folks are aware of, but it is a guaranteed response time from the operating system version of Linux. It is spectacular for simulations, so aircraft simulators, for example. It's also wonderful for financial transaction type of environments where you need that guaranteed response time, and if the system slows for 10 seconds or for a little bit, you could potentially lose millions of dollars on those financial transactions. So SLES real-time is a great solution for those that need that piece. Looking at the server extensions, which are again just modules to those base operating system pieces. And even those base operating system pieces are just modules. But we've got the high availability, which includes geo-clustering. We've got live patching, which we talked about earlier. And one of the pieces around support that really is pretty powerful for those of you that need to have operating systems or supported operating systems well past their lifespan of general support, you can get long-term service pack support. Keep them secured, patched, up to date, well outside of what their normal lifespan would have been. From a cloud and management perspective, keep in mind that we have enterprise storage, our containers platform for Kubernetes, our cloud application platform, which is Cloud Foundry based. And all of this runs as just a module on top of SLES, on top of those core common code-based components. So at this point, I'm actually going to turn this conversation back over to Rick, and he's going to bring us home with one final topic.
Thanks, Craig. I really appreciate you taking the time to walk us through those really neat features in system management and live patching and whatnot. And now we're going to wrap up by talking about a couple of different technologies that are not necessarily operating system level things, but we think that are really neat and we wanted to share with you. All right. And most of this revolves around the idea of a DevOps style build cycle of being able to package up and build your applications to be able to test them and be able to roll them out in a consistent manner. All right, we have a series of tools that we've built and we've released, and actually all of these are available as free open source projects. So this is not a product that we're pitching to you. These are actually the tools that we use internally to build SUSE Linux and our other products and be able to deliver them out to you. And we feel like they've worked great for us. We want to share them with you. First one we want to talk about is the Open Build Service. So there's two different ways that you can deploy the Open Build Service. You can either go to build.opensuse.org and you can create yourself an account there and you can build packages there. There's also an appliance that you can download from the Open Build Service website. And you can download an appliance and deploy it locally in your own data center if you don't want to use the community one that we have sitting there waiting for you. So what does Open Build Service do? Open Build Service lets you connect up your source repository, so your source code, and your build files, so spec files for RPMs, .debs, for Ubuntu and Debian-based systems. You can also do Arch-based systems and whatnot. And so what it can do is takes that code and it will automatically do package builds for you when your code changes. So you can set it up so that it's automatically building for a wide variety of systems. So it's not just a SUSE build service. It can build for all the different flavors of SUSE, of course. It can also build for all the different flavors of Red Hat and Fedora and CentOS. Scientific Linux. It can also do Arch. It can also do your Ubuntu and your other Debian-based variants. So it's a wide variety of different things, and there's a couple other ones that are thrown in there too that I don't recall off the top of my head. The point being is that you can have one source code repository with your build files for the different distributions, put it in one spot, and then automatically trigger out builds whenever you go. So for example, if you have code stored in a Git repository, for example, you can set one of your Git hooks so that whenever you do commits to your master branch, it can automatically send a message over to the open build service. Build service can pull from that Git repository and automatically build out and host repositories for the packages for all the different operating systems, Linux-based operating systems you want to have those packages for. It's a very powerful tool and it works quite well. As I said before, this is a tool that we use internally for our package builds, and we wanted to make it available for you as well. Another tool that's really neat is one called Kiwi. Kiwi is actually the tool that we use internally to be able to master out our media. But it can do more than just create ISOs, right? It can actually create a system image for deployment into a wide variety of different areas. And the functionality for Kiwi is actually built into the open build service as well. So you can either run manual Kiwi image builds, or you can have that be part of your build process inside of open build service. And when I say it can build for everything, it can build for everything. You know, if you're building for x86, for ARM, for Power, mainframe, it can build for Amazon AMIs, it can build VHDs, VMDKs, it can build pretty much anything, Docker container template images. It can build pretty much anything. It can even build raw images for blasting down onto disks. It can build DVD ISO-based media. It can build a wide variety of different things. So tying this into this overall process, right, with OBS, again, you can check in your code to your GitHub or your Git repository, have a hook there, trigger a build inside of Open Build Service, so it builds packages for everything. And then you can also have it trigger a hook to go in and then build a Kiwi image so that you actually have an operating system image there ready to go with your own custom RPM embedded inside of it, ready to be deployed in a local infrastructure, in a public cloud, wherever you need it to be. Let's see if we can get the slide to advance. There we go. The next step in this is another tool that we built. It's called OpenQA. OpenQA is an automatic testing framework, and unlike a lot of other testing frameworks where what you're really testing is the unit tests and test cases that your developers built for themselves, what this does is it actually simulates being a user interacting with either a console or a graphical environment and interacting with this application that you have built up. And you can build all sorts of test cases to tell it what to check, and then it will go through and run through all these cases and revalidate them every time. Part of our process, for example, with QA internally, is that anytime a bug gets reported to SUSE, one of the first steps we do is, once we replicate it and verify it, is to build the OpenQA test run to be able to detect and catch that bug again. And then we add that into the test suite that it's going to run. The benefit being there that it prevents regressions, so that for whatever reason you don't have somebody run the same code out, overwrite something or whatever, but you don't have the bugs creeping back into the system after it's been fixed. Once it's fixed and the test case is in, OpenQA is automatically going to be tested for every single time that we build and validate. So it's a very powerful tool, and again, it lets you create this whole chain. As I said, check in your code to Git, automatically get your package built, automatically build an image that has your package inside of it and is ready to be deployed. Then you can set up, through tools like Jenkins and stuff like that, you can set up a deployment for that image so that it gets put into your local infrastructure or into public cloud. And you can set up OpenQA to be able to go in and test that image right away, so that within a couple minutes of you committing your code into your Git repository, you can have a package built with an image, and it can already be QA'd and ready to be sent out to your customers or deployed into your internal landscape without having to worry about it. It's a very powerful tool. All right, thank you so much for coming to our session today. I hope you've really enjoyed it. I know we've enjoyed being here with you, and thank you again for being here at Digital SUSECON 2020. It's a new experience for us. Hopefully it's been an enjoyable experience for you. Thank you very much, and we appreciate your time.